Normal distribution worksheet question number 1. In the normal distribution with mean mu and standard deviation sigma, probability x is greater than 3.6 is 0.5 and probability x is greater than 2.8 is 0.6554. Write down the value of mu and calculate the value of sigma. Okay, so we know that when the mean is not 0 and the standard deviation is not 1, we must make adjustment to the formula so that it becomes 0 and 1 respectively. So what we'll do is probability x is greater than 3.6 minus mu upon sigma equals 0.5, and probability x is greater than 2.8 minus mu upon sigma would be equals to 0.6554. Okay. Now we can't read the table directly because this is greater than and this is greater than. Table is read when we have less than here. So if probability x is greater than this is 0.5, then probability x is less than this should be 0.5 as well, because 0.5 is exactly in the middle. This, the left probability or the right probability is 0.5 because the total probability is 1. So if it was saying that greater than a value is 0.5, so less than the same value would also be 0.5. Okay, next it says probability x is greater than this number is 0.6. So this would be somewhere over here because it's 0.6554. Okay, so that means this is a negative value because we have 0 here and towards the left of it there has to be a negative value. So what we'll do instead is we will project it towards the right hand side and say that this probability is equals to 0.6554. And now this number is going to change its sign because it's now becoming positive. Earlier it was negative. So change its sign, it's going to be mu minus 2.8 upon sigma. So the second equation should be probability x is less than mu minus 2.8 upon sigma equals 0.6554. Now we're ready to read the table. Okay. Just give me one second, I'm coming back. So yes, we have two equations. We're going to read the table and try to get the value of this, and then we'll get simultaneous equations that will solve. Okay, let me now cut paste the table. Okay, let's see. So the first probability is 0.5. 0.5 is right here. So the value would be 0.00. So 3.6 minus mu upon sigma is actually just 0. So 3.6 minus mu upon sigma should be equals to 0. And where's 0.6554? 0.6554. Here it is. It's also there in an exact form. We don't need to add anything further to it. So this is 0.40. So this is 0.40. So mu minus 2.8 upon sigma is equals to 0.40 or 0.4. Now we have two sets of simultaneous equations. We can solve it and get the value of mu and lambda. I'll show you the first one. And in any further questions, you'll be doing that on your own. Okay, so here mu comes out to be 3.6 and substitute it in the other equation, 3.6 minus 2.8 upon 0.4 is equals to sigma. That should get us sigma as well. 3.6 minus 2.8 upon 0.4 is 2. So mean is 3.6 and standard deviation is 2. Okay, next part. If 4 observations are taken at random from this distribution, find the probability that at least 2 observations are greater than 2.8. Okay, so this is binomial distribution. If 4 observations are taken at random, so n is equals to 4. So remember we have NCR. So here n is equals to 4. 4C. If 4 observations are taken at random from this distribution, find the probability that at least 2 observations are greater than 2.8. So probability X is at least 2. So greater than and equals to 2. So that means we have to find probability of 2. Probability X is equals to 2 plus probability X is equals to 3 plus probability X is equals to 4. Binomial distribution. Or instead, we can do 1 minus probability X is equals to 1 minus probability X is equals to 0. I think this would be slightly shorter. I'm going to do this. So 1 minus probability X is equals to 1 would be NC1. So 4C1, probability of success. What is the event? At least 2 observations are greater than 2.8. So it's this event. We already have its probability, which was 0.6554. So the probability of success is 0.6554. Power is 1. And then 1 minus 0. Q is 1 minus 0.6554. And the power is the difference of the two, 3. And then minus 4C0, probability of success, power 0, times probability of failure, 1 minus 0.6554, power difference of 4 and 0, which is 4. Okay, this would give us 0.87862. Which in 3 significant figures becomes 0.879. Answer for part 2. Okay, next question. A garden shop sells polyanthus plants in boxes containing the same number of plants. The number of plants per box which produce yellow flowers has a binomial distribution with mean 11 and variance 4.95. Okay, so we're given the mean and we're given the variance for binomial distribution. इसका formula होता था mean is equals to NP in binomial distribution. and variance is equals to NPQ. It's actually standard deviation square, so it's NPQ. Okay, so this is equals to 11 and this is equals to 4.95. So notice you can replace this with 11. So you get 11 times Q equals 4.95. So Q comes out to be 0.45. And now you can substitute it here and get N as well. No, we can't get that yet, sorry. So we just have Q for now. Okay, let's see. Find the number of plants per box. Okay, so we would need to find N. Okay, so Q is 0.45. How do we find N and how do we find P? If Q is 0.45, then P would be 1 minus 0.45, which is 0.55. And now you can substitute it here and get N as well. So N comes out to be 20 from here. So this is the solution for part A that I've done on the right. Part 1, part A. Find the probability that a box contains exactly 12 plants which produce yellow flowers. Okay. So N is 20. So we have to find probability X is equals to 12. So it's going to be 20 C 12 probability of success. What's the probability that a yellow plant is produced? It's what was our P 0.55 power 12 and 1 minus 0.55 or Q, which is 0.45 power 20 minus 12, which is 8. So this comes out to be 0.1623, which is 0.162 in 3 significant figures. Part B. Another garden shop sells polyanthus plants in boxes of 100. The shop advertisement states that the probability of an polyanthus plant producing a pink flower is 0.3. Use the suitable approximation. This statement, suitable approximation, means you have to convert binomial to normal. Convert binomial distribution to normal distribution. This is what it means. Okay, use a suitable approximation to find the probability that box contains fewer than 35 plants which produce pink flowers. So probability X is less than 35. So probability Z is less than 35 minus mu upon sigma. Mu is NP. Sigma is square root NPQ. N is 10. Sorry, 100. It was given in the question. Probability of success is 0.3. And hence probability of failure would be 0.7. So now find mu and sigma and use it in the left equation. Mu would be 100 into 0.3, which would be 30. Sigma would be square root 100 into 0.3 into 0.7. So square root of 21. Probability Z is less than 35 minus 30 upon square root of 21, which is probability z is less than, oh, I forgot one thing. Since it's conversion of binomial to uh, normal, I forgot to do the upper bound and lower bound thing, which is very important. This is not 35. It's going to be either 34.5 or 35.5. So let's see what it is going to be. So let's say 35 is somewhere over here when mean is not 0 and standard deviation is not 1. Okay, so it says less than 35. So for less than 35, we have to choose 34.5. So it should be 34.5. And in case it was less than equals to 35, then you have to choose this bar, which would have been 35.5. So in this case, since it's just less than and not less than equals to, we have to choose 34.5 minus 30 upon square root of 21. Zero 0.9819. Which is going to be read from the table. Okay, 0.9819. 0.9817, and we need to add 2 to it, so it's the closest 2. So 0.9819 would be 2.094. Okay, sorry, we were not reading the probability. We have to read the actual, we have to find the probability. So this has to be read from the sides. This is not the probability, sorry. So 0.9819 is here. 0.98. Instead of 19, I'm going to change this into 2 because we need 3 decimal places inside the brackets. So 2 is here, my bad. Because it's going to be 0.8365 and then plus 5. So 0.8365 and then add 5 to the last number. So 0.837 is the answer. Okay. Next question. The distance in meters that a ball can be thrown by a pupil at a particular school follows a normal distribution with mean 35 and standard deviation 11.6. Find the probability that a randomly chosen pupil can throw a ball between 30 and 40 meters. So probability X is between 30 and 40. Now make the mean 0, standard deviation 1 by subtracting with the given mean and dividing with the given standard deviation. Which gives minus 0.431 in 3 significant figure in X and 0.431 in 3 significant figures. All right. So we know when we have probability minus A, this is now Z. C and A here, then it's 5, 2 phi A minus 1. So what we have to do is find twice the probability Z is less than 0.431 and then minus 1 from it. So 0.431's probability has to be found from the table. Okay, please ignore the yellow markings. Zero 0.4. I cannot ignore it. Let me cut paste again. Zero 0.431. So 0.43, which is this, and add what's underneath 1, which is 4. So this is going to be 0.6664 plus 4. So 0.6668. So 2 times 0.6668 minus 1, which is going to be 0.3336 rounded to 0.334. That's the first part of the question. Next is, the school gives a certificate to 10% of the people who throw further than a certain distance. Find the least distance that must be thrown to qualify for a certificate. Okay. The school gives certificate to 10% of the students who throw further than a certain distance. Let's call that distance D. So probability X is greater than D is, the school gives a certificate to 10% of the people. So this should be equals to 10%, which is 0.1. Which means that we have to do probability X is, Z is greater than D minus mean was 35, standard deviation was 11.6, and this is equals to 0.1. So it's some value over here. Since the probability is so small, somewhere over here. So we can say probability Z is less than D minus 35 over 11.6 should be equals to 0.9. This probability is going to be 0.9. It's a positive number, so we will not be changing it into a negative number. If it were a negative value, we would have to change it into a positive value. Okay, so this is 0.1 here, not 0. Okay, now we see when is the probability 0.1. So now we read the probability. Sorry, 0.9, not 0.1. So do we have 0.9 exactly? No, we have this, and then we need to add 3 to it. We can't add 3 to it. There's an option of 2 and 4, so you stick to the smaller number. So 0.8897 plus 2 would be 0.88999. So this is 1.281. 1.281. So this would be equals to 1.281. When you solve this, you get distance is equals to 49.8596 rounded to 49.9. Okay. Next question. A manufacturer of biscuits produces 3 times as many cream ones as chocolate ones. Biscuits are chosen randomly and packed into boxes of 10. Find the probability that a box contains equal number of cream biscuit and chocolate biscuit. Okay. So first we have to find what's the probability of getting a cream biscuit and what's the probability of getting a chocolate biscuit. So what are we given? 3 times as many cream biscuit as chocolate biscuit. So you can say that 3 times probability of cream biscuit plus P equals to 1. There are 3 times as many cream biscuit than a chocolate biscuit. So 4P equals 1. So P is equals to 1 upon 4. So probability of chocolate biscuit is 1 by 4. So probability of cream biscuit would be 3 by 4. Yeah. So let me just write it here. Probability of getting a cream biscuit is 3 by 4. And probability of getting a chocolate biscuit is 1 by 4. You can also just tell by looking at the statement. There was actually no need of the working that I did. It says 3 times as many cream biscuit as chocolate biscuit. So if there's 3 cream biscuit, then there's 1 chocolate biscuit, and the probability of getting chocolate would be 1 by 4. Probability of getting a cream biscuit would be 3 by 4. Okay. So probability biscuits are chosen at random and packed into boxes of 10. Okay. Into boxes of 10, find the probability that a box contains equal number of cream biscuit and chocolate biscuit. So we're going to say probability X equals 5. That means 5 cream biscuit and 5 chocolate biscuits out of 10. So this should be 10, C5. You can use either chocolate or cream for probability of success and failure. Doesn't matter because it says equal number of cream biscuit and chocolate biscuit. So let's take cream. So then the probability of success would be 3 by 4. Power 5. And probability of failure would be 1 by 4 power 5. Even if you start with this first, power of this would be 5, and then the probability of failure 3 by 4 will also be 5. It's the same thing. Okay. So you can take chocolate as probability of success or cream as probability of success because 5 are chocolate biscuit and 5 are cream biscuit. Okay, this comes out to be 0.05839 rounded to 0.0584. A random sample of 8 boxes is taken. Find the probability that exactly one of them contains equal number of cream biscuit and chocolate biscuit. Okay, so now it's going to be 8C1. Still binomial. Now N is 8, C is 1. Now what's the probability of success? Equal number of cream biscuit and chocolate biscuit which you found here. So you have to use this as the probability of success. This is going to be 0.05839, and then here probability on power would be 1, and this would be 1 minus 0.05839, and the power would be 7. This gives 0.307. A large box of randomly chosen biscuit contains 120 biscuits. By using a suitable approximation, which means convert binomial distribution to normal distribution. So it's also, you have to take into account upper bound or lower bound. I forgot the last time, so we can't now. So probability that it contains fewer than 35 chocolates. So it's probability X is less than 35, but in upper and lower bound, 35 is here, 34.5 is here, and 35.5 is here. So it says less than 35. So that means it's 34.5. But if it were less than and equals to 35, then we would have taken 35.5. So for now, its probability Z is less than 34.5 minus mu upon standard deviation. Mu in binomial distribution is NP. Standard deviation is square root NPQ. Okay. So N is 120. You can see from the data. And what's the probability of success? Chocolate biscuit. So probability of P would be 1 by 4. Which gives 30. And this would be square root 120 times 1 by 4 times 3 by 4. Which gives 4.7434. $34.5 minus 30 upon 4.7434. This gives probability Z is less than 0.9487. Okay. If we're reading the table, then this should be in 3 significant figures. So probability Z is less than 0.949. Okay, let's read from the table. Zero point 0.949. Okay, so 0.9 at the left here, 4 here. So this, and add what is underneath 9, which is 23. So 0.8264, 23, and with the last 2 digits. So 0.8287. That's the answer. Okay, that is all for today. Please try to do question number 5 as homework, and we'll discuss any problems you have tomorrow and start with question number 6. Allah Hafiz. Take care.